Hello, welcome to the course on oceanography. This is for the JAYOTI VIDYAPEETH Women's University. In this lecture, we will discuss about oceanography, what it studies, what it deals with, and also the distribution of water on the Earth's surface, distribution of land and water on the Earth's surface. So, first of all, we will define what oceanography means. Oceanography is basically the study of physical, chemical, and biological features of the ocean, including the ocean's history, its current condition, and its future. In a time when the ocean is threatened by climate change and pollution, coastlines are eroding, and entire species of marine life are at risk of extinction, the role of oceanographers may be more important now than it has ever been. And the oceanography studies the distribution of oceans and water on the surface, their characteristics, their salinity, alkalinity, the resources in the oceans, the problems in the oceans like pollution and degradation, and the change of the water quality of the oceans, and also the positive features that are associated with the oceans, like for example some of the economic activities. People in different countries, they depend on oceans for their livelihoods, for example for fishing and other resources from the oceans. So these fish cultivation, it becomes, or the fish production, or the catching of fish, it has become an important activity, important economic activity in many parts of the globe. And these fish are being exported or imported, which helps the trade relations and also in the economic relations of different countries. So that is basically oceanography, and it studies the features of the oceans and features of the water, their distribution, and the countries that are associated with these oceans. That is the core of oceanography. Indeed, one of the most critical branches of oceanography today is the biological oceanography. It is the study of ocean's plants and animals and their interactions with the marine environment. But oceanography is not just about study and research. It's also about using that information to help leaders make smart choices about policies that affect ocean health. Lessons learned through oceanography affect the ways humans use the sea for transportation, for food, energy, water, and much more activities. For example, the fishermen with the Northwest Atlantic Marine Alliance (NAMA), NAMA, that's the in short, that's the short form of it. They're working with oceanographers to better understand how pollutants are reducing fish pollutions and posing health risks to consumers of the fish. Together, NAMA and ocean scientists hope to use their research to show why tighter pollution controls are needed. Oceanographers from around the world are exploring a range of subjects, such as wide the ocean itself. For example, teams of oceanographers are investigating how melting sea ice is changing the feeding and migration patterns of whales that populate the ocean's coldest regions. National Geographic explorer Gabriel Corradino, a North Carolina State University 2017 Global Change Fellow, is also interested in marine ecosystems, though in a much warmer environment. Corradino is studying how the changing ocean is affecting populations of microscopic phytoplankton and the fish that feed off them. Her fieldwork included 5 weeks in the Gulf of Mexico, filtering seawater to capture phytoplankton and protozoa, the tiniest but most important parts of sea's food chain. Of course, oceanography covers more than the living organisms in the sea. A branch of oceanography called geological oceanography focuses on the formation of the seafloor and how it changes over time. Geological oceanographers are starting to use GPS, that is a global positioning system, technology to map the seafloor and other underwater features. This research can provide critical information such as seismic activity that could lead to more accurate earthquake and tsunami prediction. In addition to biological and geological oceanography, there are two other main branches of sea science. One is physical oceanography, that is the study of the relationships between seafloor, the coastlines, and the atmosphere. The other is chemical oceanography, that is the study of the chemical composition of seawater and how it is affected by weather, human activities, and other factors. When we talk about the distribution of water on the Earth's surface, about 70% of the Earth's surface is covered by water. Nearly 97% of that water is the salt water swirling in the world's oceans. Given the size of the oceans and the rapid advancements in the technology, there is seemingly no end to what can and will be uncovered in the science of oceanography. Okay, so when we talk about the distribution of water on the Earth's surface, Earth is known as the blue planet because 71%, almost 70 to 71% of the Earth's surface is covered with water. Water also exists below land surface and as water vapor in the atmosphere or in the air. Water is a finite source. The bottled water that is consumed today might possibly be the same water that once trickled down the back of a woolly mammoth. The earth is a closed system, meaning that every little matter, including water, even leaves or enters the atmosphere. The water that was here billions of years ago is still here now. But the earth cleans and replenishes the water supply through the hydrological cycle. The earth has an abundance of water, but unfortunately, only a small percentage of about 0.3% is even usable by humans. The other 99.7% is in the oceans, soils, ice caps, and floating in the atmosphere. Still, much of the 0.3% that is usable is unattainable. Most of the water used by humans comes from rivers. The visible bodies of water are referred to as surface water. The majority of fresh water is actually found underground as soil moisture and in the aquifers. Aquifers are like veins in the earth's ground under the earth that are in which water is filled. And when you cut it or when we dig a tube well or a well, we find water, and that water comes from these aquifers. So groundwater can feed the streams, which is why a river can keep flowing even when there has been no precipitation. Humans can use both underground as well as surface water. And the distribution of water in terms of percentage, ocean water is 97.2%, glaciers and other ice water, that's 2.15%, groundwater is 0.61%, freshwater lakes 0.009%, inland seas 0.008%, soil moisture 0.005%, atmosphere 0.001%, and rivers 0.0001%. Or we can explain it in different ways also. We can say that the distribution of water on the Earth's surface is extremely uneven. Only 3% of water on the surface is fresh. The remaining 97% resides in the oceans. Of fresh water, 69% resides in glaciers, about 30% is underground water, and less than 1% is located in lakes, rivers, and swamps. Looked at another way, only 1% of the water on the Earth's surface is usable by humans, and 99% of the usable quantity is situated underground. All one needs to study rainfall maps to appreciate how uneven the distribution of water really is on the surface of the earth. And like about the 100% of water that is present on the surface of the earth, 97% is the ocean water and 3% is the fresh water. In fresh water, this around 30% is the groundwater and 68.7% is the ice caps and glaciers, and around 1% is the other sources, that's lakes and fresh water. That is basically the distribution of water on the earth's surface. Okay, thank you.